In section 2, we're going to look at combinations or permutations with repeats. What we're going to do is we're going to create a permutation and we're going to unorder part of that for different reasons. In our first example, it says how many unique ways can you write out the letters in robot, R-O-B-O-T. And so normally we would say, well, we have 5 letters. So we have 5 choices for the first one, 4 for the second, 3 for the third, 2, and then the last one is the one we're stuck with at the end. And we multiply those all together and we would get 120. Now the issue is, in the word robot, is that we have an O and an O. And if we were to switch these, the word would look exactly the same. And in fact, any way that you put the letters in some kind of order, you could switch the O's and never notice that anything changed. As a result, we need to divide our answer by the pair we have factorial, which is another way of saying we need to divide it by 2 times 1. And we know that 2 times 1 is 2. So I'm going to actually just scribble that out. But just make sure that you are aware that it is a factorial. So 2 times 1 is 2. If we had 2 pairs of things, let's say that there was R-O-B-O-R, and the R's were the same, we would have to multiply it by another 2 factorial in the denominator in order to deal with that. So just be aware that you can have multiple repeats. If we do this, we know that 120 divided by what it equals 2 here is going to be 60. So we're going to cut that number in half. So how many ways can you write out the letter in robot that are unique? It's not 120, it's actually 60. Same concept applies here for number 2. You'll notice we have a whole bunch of F's and all the other letters are unique. So go ahead and take a shot at that. This one says if you have 10 students, how many ways can you choose a group of 5 where order does not matter? In this case, we're going to also do the same process we've done where we figure out our permutation, where we find the blanks, fill those in, get a number, but then at the end it says order of the group does not matter. So we need to unorder those people. We're going to have our first blank where we have 10 students to choose from. We have 1, 2, 3, 4 more blanks, so we have 9 students remaining after that, then 8, then 7, then 6, and we're going to multiply those numbers together. So go ahead and do that. You have 10 times 9 times 8 times 7 times 6, and you're going to get 30,240. So big numbers. But it says the order of the 5 students doesn't matter, so we are going to divide that by 5 factorial. And if you remember from before, 5 factorial is 5 times 4 times 3 times 2 times 1, which we said equals 120. So we're going to say that this is equal to 3,240 all over 120. And when we divide out that 120, we end up with an answer of 252. So there are 252 ways to choose a group of 5 where order doesn't matter when you have 10 people. Seems kind of crazy because that's half the people in the room. There's 252 different ways to make up that group. Same concept applies for number 4. You're going to follow the exact same pattern where you start with the room of 8 people. Work from that and then unorder the 6 by using that 6 factorial to unorder those 6. Good luck.